Point slope form of linear functions. So the definition of point slope form is the slope, a line with slope m and through any point x1, y1 is given by this equation here. So the pieces of this, m is exactly what it should be. M is your slope. Slope of the line. The new part is the x1, comma y1. This can be any point on the line, x1 here and y1 here. It doesn't have to be the y-intercept anymore. It can be anything. Okay, now x and y, the regular x and y, have to stay x and y. This is your independent and your dependent variable. You need both to make an equation. So for example number 1, a line passes through -3, 6 and has a slope of -5. What is the equation of the line in point slope form? So before we've been just dealing with slope intercept. Now we have another way of writing a line. So make sure you're paying attention to what kind of equation you want. So I know that the line passes through -3, 6 and it has a slope of -5. So the first step is finding all your pieces. So my m is -5. And that coordinate that it runs through is -3, 6. So this here is the x1. So x1 is equal to -3, and this guy here, y1, is equal to a +6. Once you have all your information, step 2 is to go substitute the given information into the point slope form, which is y minus y1 equals m times x minus x1. So let's go plug in our information. So we have y minus, and then y1 is a 6. Equals m, which is a -5, times x minus, and then x1, which is a -3. And once we have everything plugged in, let's see if we can clean this up by maybe distributing negatives. So if I distribute a negative here, a negative and a positive will make a -6. -5 stays on the outside, and then negative times -3 is going to be a +3. And this is the point slope form right here. This is it. This is point slope form. Now, for some practice, if you were asked to convert into slope intercept form, well, slope intercept is y equals mx plus b. Notice what is alone on the left-hand side. So with slope intercept form, y is by itself. So if you were asked to take this point slope form and to convert it into slope intercept, you'd be solving for y. So let's practice that. So y minus 6 equals -5 times x plus 3. So to convert this into slope intercept, we want to get y by itself. We want y alone. So step 1 would be to distribute. So y minus 6 equals -5x, and then -5 times 3 is a -15. And then the last step to get y by itself is to simply add 6 to its like term on the other side. So this would turn into y equals -5x, -15 plus 6 makes -9. So this is the slope intercept form version of the same equation in point slope. These are both the exact same line. Notice they both have a slope of -5. The only difference is in slope intercept, I know that my y-intercept is -9. So sometimes this is more useful because you have the y-intercept. So for example 2, a line passes through points 1, 4 and -2, -3. What is the equation of the line in point slope form? So no need to convert it. Well, first step is to find your pieces. Well, the first piece I need for point slope form is a point, which I have. I have 2 points. I'm going to choose the one that has the most positive. So I'm going to choose this one. So x1 is 1 and y1 is 4. The next thing I need to find in point slope form is, well, the slope. Well, they didn't give me the slope this time, so I'm going to have to use my slope formula to help me find the slope. y2 minus y1 over x2 minus x1. So label my points. Here's x1 and y1. Here's x2 and y2. Okay, and then let's plug in. So y2 is -3 minus y1 of 4 over x2 of -2 minus x1 of 1. And we end up with -3 minus 4 makes -7. -2 minus 1 makes -3, which simplifies further into +7/3. Now that we have the slope and a point, it didn't matter which one we picked, so we just picked this one. We can plug in and use our point slope form. So let's plug in our information. So y minus and y1 is a 4 equals m, which is positive 7/3 times x minus, and then whatever x1 is, which is a positive 1. So now let's distribute and try to see if we can simplify. So negative and a 4 makes, well, negative 4, nothing changed there. 7/3, and then x, negative and a positive 1 makes negative 1. So this would be one of the correct answers for this problem. That's one of the correct answers. However, if you were to choose negative 2, negative 3, so let's say we picked negative 2, negative 3. This would now be x1, and this would now be y1. So if we plug these guys in, y minus y1 of negative 3 equals m times x minus x1 of a negative 2, and distribute, minus a negative is a plus, equals 7/3 times x minus a negative equals a positive. This is another correct answer. This is another one. So there's two possible answers to this problem. You only need to write one of them because it wasn't specific. Now I want you to notice a pattern here. When I used 1, 4, the x was a positive 1, but when you look at the equation, it's a negative 1. When y was a positive 4, the equation shows negative 4. When I used negative 2, negative 3, when x was negative, the equation showed positive. When y was negative, the equation showed positive. And same thing on this example number 1 from earlier, negative 3, 6. The x was negative, but in the equation it was positive. Y was positive in the point, but negative in the equation. So the coordinate signs and the equation signs are always backwards, and that comes from these little negatives right here in the front. That's what makes the signs of the coordinate change. So take a minute, see if you can try examples 3 and 4 on your own. Here's what you should have had for your 2. So for example number 3, the y-intercept is a negative 5. And we have to remember that a y-intercept is 0, the y value. So this actually is a coordinate point. It's just not quite spelled out for you. So when you have a y-intercept of negative 5, that is really the point 0, negative 5. So you should have ended up with y plus 5 equals 3x. Now this went away because x minus 0 is just x, and then 3 times x is simply 3x. On example 4, you have two possible answers. You could have used y plus 4 equals negative 1/7 times x minus 5 if you used the coordinate 5, negative 4. Or you could have had y plus 3 equals negative 1/7 x plus 2 if you use the coordinate negative 2, negative 3. Let's look at graphs and tables. So graphs and tables still need the same two pieces. I still need my slope and I still need any point. I don't have to have the y-intercept this time. So if we try to find slope on number 1, let's pick 2 points. So let's pick, I don't know, this point. So negative 4, 3. And we can pick this point here at negative 1, negative 3. So this can be x1, y1. This can be x2, y2. And let's go plug it in our formula. So negative 3 minus 3 over negative 1 minus a negative 4. So this is going to turn into a positive. Negative 3 minus 3 makes negative 6. Negative 1 plus 4 makes 3. And negative 6 divided by 3 makes negative 2. So there is our slope. So again, you can choose any point you wish. Since we labeled this top one x1 and y1, let's just go ahead and use that point. So x1 is going to be negative 4, and y1 is going to be a 3. And let's plug in to our slope intercept, or our point slope form. So we have y minus y1, which is really a 3, equals m of negative 2 times x minus x1, which is negative 4. And then simplify if we can. Minus and a positive still makes a minus. Negative 2 parentheses, x, negative and a negative make a positive 4. And here's the point slope form. And again, tables, no different. Write the equation in point slope form. So we are going to, I got to find my slope. So step 1 is finding slope. So pick any 2 points you want. So let's use the positive ones to make life a little bit easier. And let's plug into our slope formula. So y2 is 16 minus y1 of 10 over x2 of 17 minus x1 of 8. So we've got 6 over 9, which will make 2/3. So there's my slope. And for the point slope form, it doesn't matter which point we pick, but since we labeled this guy x1, y1, let's go ahead and choose that one. So 8, 10. Positive 8, 10. So that means 8 is my x1 and 10 is my y1. So when we plug this into our formula, it's going to be y minus y1, which is 10, equals 2/3 times x minus x1, which is an 8. And then simplify. So negative and a positive make a negative. Y minus 10 equals 2/3 times x minus 8. And this would be our point slope form. So take a minute, try number 7 and 8. Here's what you should have had for both 7 and 8. Keep in mind, if you use different coordinate points, you will have different answers for 7 and 8. Graphing in point slope form. So the big idea for this one is you've got to remember that when you use your coordinate x1, y1, the signs in the equation are opposite from what they should be in the coordinate. So plot the point that's given, use your slope to find some more points, and then connect your dots. So first thing that's easy is the slope. This is your m, as always. So my slope is still positive 2/3. That's still my slope. The coordinate, however, is a little bit different. Remember your layout. Y minus y1 equals m times x minus x1. So the y's always hang out together. So this 1 is actually your y1. The 2 is your x1. But remember, the signs are backwards. So for the x value of your coordinate, the equation shows it as -2, which means the coordinate is actually a +2. Same thing for the y value, it's backwards. If the equation shows a -1, your coordinate is actually a +1. So this is going to be the point we start with. So plot 2, 1, and then use that slope up 2, right 3 to plot some more points. So up 2, right 3, plot a point. Up 2, right 3, plot a point. When you run out of room going up and right, flip around both directions. So move down 2 and left 3. Notice we did not start from the y-intercept this time. We started from the coordinate that was given. As long as you have a point to start with, you can graph a line. For slope-intercept form, that point is the y-intercept. For point-slope form, that point is whatever is shown in the equation. So take a second, try example 10. And here's what you should have had for number 10. So your slope is a -1/2. Take that negative and pull it to the top. So it's a -1 over +2. So down 1, right 2. And your coordinate is the x value of a +4 because it's always backwards. So +4, comma a -2 because it's always opposite. If this shows plus, this guy is going to be a negative. Plot your point first, plot your 4, -2 first, and then use your slope from that point to move down 1 and right 2 over and over and over again until you get your line created.